So a lot of the time when writing a program, you'll come across a point in a problem where you have to do one thing, potentially, if a certain condition is met, or you might have to do another thing if not. So think about dealing with a value in different ways depending on if it's positive, for example, or if it's negative. You might have to run different code to deal with both cases, and so you'll want to have what we call a conditional operator. Sometimes also we use the term if statements, probably more frequently we call it if statements, else statements, that type of stuff, to basically write code that runs conditionally. So what does it mean for something to be conditional? So I'll show you a couple of conditional statements in Python. For example, first one, 1 equals 1. This is a conditional statement asking, does 1 equal 1? Or is the left-hand side equivalent to the right-hand side? We always use two equal signs here to differentiate this between variable assignment. Remember, when we assign variables, we'd use a single equal sign. So in Python, an equal sign is assignment, and double equal sign is equality, like an equality operation. So this is asking, is the left-hand side equal to the right-hand side? And the result here would be true. So if I assign this to a variable, like this expression would return true. The next one is, or just as an example, I'll say if it was 2, for example here, is the left-hand side equivalent to the right-hand side? No, so it would return false. There's other operations you can also do, like for example, not equals, which is essentially just the opposite of this. So is 1 not equal to 1, or left hand not equivalent to right hand? In this case, false. They are the same. And here our answer would be true, because they are in fact different. There's other conditional operators you can use, like for example, greater than or less than, as well as less than or equal to, and greater than or equal to. So in this case, 1 is less than 2, this would be true. 1 is greater than 2, this would be false. 1 is less than or equal to 1, this would be true. 1 is greater than or equal to 1, this would also be true. So what is the purpose of these statements, right? The main purpose is to use them in conjunction with something we call if statements to conditionally run a piece of code. So for example, at the bottom of our program, I'll write an if statement here, and it goes like this. So it says if, and then we put our condition. So let's pick one of these. If 1 is equal to 1. I'll copy that, paste it here. So if 1 is equivalent to 1, and then I add the colon symbol, and I'll press enter on a new line. And you'll notice that the editor automatically adds a couple of spaces ahead. This is called indentation, and this is how we know that this code that we're about to write exists within a block. So if I write the code print 1 is equal to 1. This print statement is indented, and that lets us know that it's within this if statement. So only when this if statement, the condition within it, is true, will this code run. If we want to add something below, we simply remove those spaces and write what we want to write. Now the code that's been indented here is nested within this if statement. Right, this is a really important concept. It's nested within this if statement, which means it will only run if the if statement is true. So in this case, can you predict what the outcome of the program is going to be? Well, it's going to print this line because 1 is in fact equal to 1, and then it's going to exit the if statement, and it's also going to print this line. So if I run this, we'll see that's what happens. If I change this value here, for example, from 1 to 2, we know that this is not true. And if I run the program again, you'll see that that line won't actually be printed. Only the hello gets printed at the end. So it's really important to indent here. If I didn't indent and I wrote something like this, we would probably just get an error. Yeah, see, we get an error. Because it's expecting, after this colon, it's expecting that the next line is indented to start a block of code. So we can also add an else statement, which would be code that gets run in any case where the condition is false. So that would look something like this, where you just write else, and then you add that colon again to start a new block of code. And I can print other case, for example. And now if I run this, we know 1 is not equal to 2, so this line will not run, but we've added this else statement, which will run in any case when this is false. So we will end up seeing the text other case printed to the console, as well as this line at the bottom. And there we go. Okay, so this might be a lot to think about. So what I'm going to do is I'm going to go over an example, 2 examples actually, and I'll ask some questions with that and I'll answer them myself to hopefully give you a better understanding of how if statements work. And then what I'll do is I'll give an exercise, and I'd like you to pause the video, try it for yourself, and then come back and I'll go through the solution. Okay, here's the first example. So I'm creating a variable called guess, assigning it to integer version of input from the user. We're going to ask the user, guess my age. Convert that result to an integer, store it in guess variable, and then I'll write an if statement. If guess is equivalent to 24, print you got it. Else, print sorry, that is incorrect. So this is the program. And the questions I want to ask is first, why is a double equal sign used in line 5? Okay, second, state the output of the program if the user enters 14. Next, what will happen if the user enters a value of 15.5? Explain. And then, would the program still run if lines number if lines number 5 and 6 were omitted? Explain. Okay. First question, why is a double equal sign used in line 5? So remember we talked about double equals being an equality check, a condition that checks if the left-hand side is equal to the right-hand side. So what we want to do here is we want to know if this is the case and it's true, there's a specific block of code that we want to run. So that's what this double equal sign is used for, to determine if the left-hand side is equal to the right-hand side. Okay, next, state the output of the program if the user enters 14. Okay, so let's assume here, input guess my age, and the user enters 14. It gets converted to an integer, so it's now a number under guess here. And then we have this if statement asking if guess, which is the value 14, so if 14 is equal to 24, well, no. So this code won't be run, but because we have an else statement, this code will be run. So the program will end up saying, sorry, that's incorrect. And the easiest way to verify this is by running it and trying it yourself. So I'm just going to click run, guess my age, put in 14, and there we go. It does say, sorry, that is incorrect. Okay, next question. What will happen if the user enters a value of 15.5? Explain. Okay, so first things first, 15.5 is not equal to 24, so you might think that it would just print out, sorry, that's incorrect. But if you remember from the previous video, here we're converting to an int, which is a whole number. But if the user inputs 15.5, which is a decimal number or a float, we can't convert that to an int, so the program would crash. Again, the easiest way to verify this would be to just try it yourself. So let's give it a shot. Run, guess my age, 15.5, and there it is. The program crashed. Okay, last question. Would the program still run if lines number 5 and 6 were omitted? Explain. So lines number 5 and 6 is this line here, if guess is equal to 24, and this line here, print. You got it. So would the program still run? Again, the easiest way to check, we can just remove those lines, run the program, and we can see that it doesn't. It has an error. It's called a syntax error. Okay, so let's put that back. Now let's think about why. Well, here we have an else statement, and an else statement is supposed to be used always in conjunction with an if statement to catch any other cases where the condition placed in the if statement isn't true. So if we remove this, there's really no condition for this else statement to go off of. It's kind of pointless. Basically, this code, the intention behind this code would just be something more like this, where we just have a print statement. So if you want to write an else statement like this, you always need to have an if statement beforehand, because an else statement is just used to catch all those other cases where this condition isn't true. Okay, let's go ahead and do one more example. So x equals float input, please enter a value. If x is greater than or equal to 0, root equals x, exponent 0.5, print square root of x is root, else print square root of x is not a real number. Okay, so there's three questions for this one. First, what is the purpose of the if-else statement used in this program? Second, describe what this program does. And third, what will be the output of the program if it is run with a user input of minus 4.0. Okay, so the first question, what is the purpose of the if-else statement used in this program? Well, if you caught on, what we're doing here is we're getting a square root of a value that the user provides. So we want to make sure that the value that the user provides is actually, it's possible for us to get the square root of it. And so if you know you can't get a square root of a negative number, it becomes an imaginary number, I think is the word. And so we use if and else to check and make sure that x is greater than 0 before trying to get the square root of it. So that's the purpose of the if and else statement. In a blanket case, you can say the if-else statement is used to run a certain bit of code conditionally and another bit of code if that condition fails, right? Okay, let's describe now what this program does. So I kind of went over most of it in the previous answer, but first step, it prompts the user to enter a value, and it converts whatever they enter into a float and stores the result in a variable named x. Okay, then it runs this if statement to check, is x greater than or equal to 0? If that's true, then it will store the square root of x in a new variable called root, and it will print a response to the user. In this else check, it's basically saying, okay, if x is less than 0, or if it's a negative number, then it will just print out this statement saying that the square root of x is not a real number. Okay, and the last question is, what will be the output of the program if it is run with the user input of minus 4.0? Well, let's just run it and find out. So please enter a value. We'll put in minus 4.0. And you'll see that it says the square root of minus 4.0 is not a real number. And just to check the other case, let's run the program one more time. And we'll say 16. And we're expecting a value of 4 here. And yep, it tells us the square root of 16 is 4. Okay, now let's do the exercise. So, a program is to be written to calculate unknown side lengths in right triangles. First step, create a program that calculates the length of the hypotenuse based on the lengths sorry, my microphone cut out again. Based on the lengths of the other two sides entered by the user. B, create a program that calculates the length of the unknown leg based on the lengths of the hypotenuse and the other leg entered by the user. Okay, next, using your programs from parts A and B, create a new program that allows allows the user to first choose whether the hypotenuse or another side length is to be calculated. And then finally, modify your program from part C to display the message, the hypotenuse must be longer than each leg when applicable. Okay, so pause the video now, give this question a shot, then come back and I will show the answers. Okay, let's do part A first. Create a program that calculates the length of the hypotenuse based on the lengths of the other two sides entered by a user. So that will look like this. So the first thing we want to do is we want to grab the length of the first leg from the user, enter the length of leg 1, and we'll do the same for the second one. Now we have those two values stored as floats in variables named leg 1 and leg 2 respectively. Next step, we have to calculate the length of the hypotenuse, so we'll use the Pythagorean theorem. So hypotenuse equals leg 1 squared plus leg 2 squared, and all of that square root. And then we can print the length of the hypotenuse is hypotenuse. Let's give this program a shot. Enter the length of leg 1. Okay. 12. Leg 2, 12. The length of the hypotenuse is 16.9705, yada yada. Okay. Next step. Create a new program that calculates the length of the unknown leg based on the lengths of the hypotenuse and the other leg entered by the user. Okay. Let me just comment this out. So you can comment by holding Control or Command and pressing the / key. I don't want to get rid of it, but we need to write this new program. So, okay. Start off the same way by grabbing user input. Float input, enter the length of the hypotenuse. And leg 1 equals float input, enter the known leg length. So again, we start out the same way. We grab some input from the user, convert it to a float, store it in the respective variables. Then we run our calculation. Now we want to determine what the length of leg 2 is, so that would be hypotenuse squared minus leg 1 squared, all square rooted. And then we can print the length of the other leg is leg 2. So let's run this program now. And we'll use the same values, try to get something similar. So the length of the hypotenuse is 16.97. The known leg length is 12. And the other leg is 11.999, so it's very close to 12. So, okay, that worked. Okay, next problem says, using your programs from parts A and B, create a new program that allows the user to first choose whether the hypotenuse or another side length is to be calculated. So in this case, we need the user to be able to make a choice. So I'm going to go ahead and comment all this out as well. And we'll start on part C. So the first thing is the user needs to make a choice. So put down here, type equals int input. Are you finding the hypotenuse? Enter y or enter 0 for no, 1 for yes. And then now, since we've got their answer, type or typ variable will be 0 if they are finding the hypotenuse, or sorry, 1 if they're trying to look for the hypotenuse, and 0 if not. So we'll say if typ equals 1, and here is where we'll put all of our code for finding the hypotenuse. So that was here. So I'll take all of this, uncomment it, then I'll cut it and I'll paste it there. Make sure that each line is indented so that it's actually nested within this if statement. Okay, and then we can add the else statement. Basically, if they did not type a 1, if they typed a 0, then we can grab all this code, uncomment it, cut it, and paste it here. Okay. So this is the program. Should be good to go. So let's give it a shot. We run. Are you finding the hypotenuse? Enter 0 for no, 1 for yes. So, okay, yes, let's find the hypotenuse. Enter the length of leg 1. We'll do 12 again and 12 again. And we get the same result. Now let's try it again for the other case. This time we'll type 0 for no. Enter the length of the hypotenuse. Okay, so it's working as expected. 16.97. We'll put 12, and it shows us the answer of 11.999. Okay, now we can move on to the last step, which is modify your program from part C to display the message the hypotenuse must be longer than each leg when applicable. Okay, so when is the case where the user might enter a hypotenuse that's shorter than the length of some leg? Well, it's this case here when they give us the length of the hypotenuse, because in this one it's being calculated. So here they might enter something small, smaller than the length of the side that they type afterwards, right, that they input afterwards. So right after these two values are inputted, we can run another if statement in here, and we can say if the hypotenuse is less than or equal to leg 1, then we can say print the hypotenuse must be longer than each leg. Right? And then we can say otherwise, else. We'll cut this code out, paste it here, and there we go. So basically, if the hypotenuse is less than or equal to the side that we entered, it'll tell us that that's not valid. Otherwise, we know that it's fine, and we run the calculation. So let's give this a shot. Are you finding the hypotenuse? No, 0. Length of the hypotenuse, we'll put 12, and then we'll put something bigger like 16, and it tells us, okay, that's good. And then we'll go for the successful case as well, just test that one too. So 0, 16.97, and 12, and we get 11.999.